Yeah, welcome back all of you. Let us start with one more complex question in orthographic projection. So here you have an object and you need to draw the multiple views assuming that the observer is here facing x direction. So let us first decide the maximum length of the object. So if I stand along x direction facing the vertical plane behind, the length is from this corner, if you count, 40 plus 75, 40 plus 75. But if you look at this 75 and if I extend this line above, it is shown up to this point. So 75 is up to this point. So I need to further add the radius of the circle. So radius of the circle is 25. You can see here. But this radius 25 is from the center and it doesn't coincide with this point. So to get the exact length, what we should do is we have to add this 40 plus 75, move up. Then you have to come behind by 6 because half of 12 is 6. So 40 plus 75 minus 6. After minus 6, what happens is you reach the center and then you can add 25. So once again, let us see the length. From this point it is 40 plus 75, but 75 is till the end of the plate. You need to subtract 6 millimeters so that you arrive at the center of the circle and then you can add 25. So by doing all these activities, we'll get the length as, let me write down the length in detail over here. So length of the object is 40 plus 75, 40 plus, so 40 plus 75 minus, you have to come by half the thickness of the plate, that is 6 mm. So 40 plus 75 minus 6, correct? And once you reach minus 6, you have to add the radius because the outermost part in the front view is the boundary of the circle. So cylinder is outside as compared to the plate. So you can very well see that this plate is inside and the boundary of the circle is outside. So you have to add the radius. So plus 25. So this will give you length as 134 millimeter. So see, you need practice to find length also. Now height of the cylinder. From bottom you need to add the thickness of the plate because 65 mm this height is from the center of the circle till the top of the base plate. This is the base plate. So 65 is till the top. So you have to add 65 and the thickness of this plate, that is given as 15. So 15 plus 65 and radius of this outer circle is how much? 25. So you have to add 15, 65 and 25. So the height what we will be getting is 105. Now if you look at the width of the object, there are two cylindrical surface. One is this one, second is this one. So this you can see is much broader, it's much wider. So the width of the object is straight away 70. Nothing to add or subtract. So width is 70. And we need to draw front view along X, top view and left hand side on the right. So first let us prepare 3 box and then we can start. So let me leave some space from this side. So from here I leave some safe gap and draw a light line, and even from above I will leave some safe gap and draw a light line. So this is our reference point. So let me write down the length width height again over here. So the length of the object, okay, so the length of the object is 134. Height of the object is 105 and width of the object is 70. Okay, so this is our reference point and we need to reserve space for front view over here below that top view, and here we have left hand side be on the right. So let us start preparing the box. So front view comprises of length and height, we know that. So we'll mark length 134 horizontal and we'll mark height 105 over here. So let us mark 2 points. So length is 134. So I'll mark 134 over here and height is 105. So from here we'll mark 105. Yeah, so I've drawn a light line over here. Let me extend that light line till bottom. After that, height is 105. So parallel to this topmost edge, from here I'll roll down and draw a light line. So this box is our reservation for the front view. We need to accommodate front view within this. Now the gap between two views is 20 mm. So I'll mark 2 from this point. I will roll this down and I will extend this. Actually not required to extend because 45 degrees from here itself. Okay. Now we need to mark width. So from this point we have to come down by width because this space is for front view. This is the gap between the views. So top view has to be drawn somewhere here. And top view comprises of length and width. So width is 70. We need to mark 7 over here. Okay, I'll align the roller scale. And from here we can draw a light line. Once this is ready, from this reference point, I'll align the protractor and mark 45 degree. And with this reference, we can draw a medium dark line so that we can draw box for side view also. So now for the side view, you can see that wherever this width intersects 45 degree line, that is at this point and this point, both these points we need to project up so that we can get the box for the side view. Okay, so let's see how to do that. So I'll align the roller scale with this line. I will roll further and draw a light line upward. And same from here. I'll align this further. So that is how 3 boxes are ready. So this is the box for the side view. Okay. Yeah, so now let us start with that view where you can see maximum circles. So in this question you can see 1, 2, 3 and a semicircle from the front view. So it is advisable that we should start from the front view. So let us locate the center of these 2 circles first. So we'll start from the topmost circle. So if you look at this circle, radius is 25 and in the front view the position of the circle is towards the extreme right side and above. It means if this is our front view box, this circle has to be tangent to the sides of the box, which is on the top and the right side. It should be tangent like this. Okay, so if you try to visualize from the front and compress the object, this circle is on the extreme top, isn't it, and on the right side. So let us look at the center of the circle by marking 25 from either sides. So the center is 25. So from this boundary it is 25, from the top boundary it is 25. So let us quickly mark the center, say this is 25. Okay, another center you have to come down by 25. So you have to mark 25 down from both the sides. Next, with the help of this roller scale, we will draw parallel lines. First here and second down. So this is the center of the two concentric circles with diameter 36. It means radius 18. So the inner circle is 536 and the outer circle is radius 25. Okay, so we will draw two concentric circles of radius 18 and radius 25. So one more way to mark is, the radius 25 is already ready. 18 you can mark a point. So this dimension is 18. So we can set our compass with both 25. First we'll set the compass with 25. It doesn't matter if the circle doesn't intersect or it doesn't pass as tangent to the circle. Suppose the circle is not tangent to the line, it's okay. If the circle doesn't intersect the straight line, it is still acceptable. So important is that you have drawn a circle. It is not important that this circle, if it is not tangent with the line, or if there is a small gap, or if it has crossed the line, all three answers are acceptable. So don't worry much about the accuracy part. Completion is more important. Now after this, we can set this dimension from year to year and draw a dark circle over here. So we have drawn two dark circles. So once both the circles are ready, let us go back to the question and now locate the center of this circle. So there you can see there is a circle and a semicircle over here. So if you look at the center, there is a line going out and it points 30. So this is 30. If it is not readable, let me tell you, this is 30. So from bottom edge, you have to move up by 30. And the another dimension, if you look here, the vertical center is 40 mm from the end of the object. So one dimension is 40 from the left side and 30 from bottom. Okay, so accordingly, we will move 40 from the left side. So I'll mark a point at 40 and from here we will move up by 30. So let me align the scale. Okay, so here I'll draw a light line and we'll move up by 30. So this point is 30. Okay, so let me check. Yes. So this is the center of the next circle and semicircle. So the circle, if you observe, it is 24 mm diameter, 24 millimeter diameter, that is 12 mm radius, and the outer one is 20 radius. So one is 12, another is 20. So let us mark 12 and 20. So from here, if I align, roll and move up, so the inner one is 12, so I'll mark 12 millimeter here, and the outer one is 20. So this is one more very good method of drawing circles quickly. You mark radius here itself and then just turn the compass. So instead of setting 12 and 20 in the compass, you mark on the paper and then by compass you can directly turn a circle and a semicircle. So remember, the inner one is a circle, inner one is circle. So let us draw the full circle first. So I have drawn full circle over here. And the outer one is a semicircle. Suppose front view carries 5 marks, and if a student draw up to here, then he or she must get 1.5 to 2 marks at least. So it is not like that in orthographic that if you complete the view, then only you will get marks. Even if you draw partially, you will still get marks. But our objective is to complete, not to draw partially. Okay, let us see the next very important part of the question. So in this particular question, I can see two ribs. I hope all of you remember what is a rib. The rib is a plate which supports other part of the object. So see, we will call this as rib 1, which is a trapezium type. So this rib supports both the cylinders, you can see that. Second, you can see a trapezoidal plate. So this rib supports the cylinder with the base. So let us call this as the base plate. So this is the second rib. So you can see two ribs, 1 and 2. Now we are drawing the front view, isn't it? So in the front view, after drawing the circles, the base plate can be seen clearly. What about this curved portion we have discussed before also? So this curved portion, if you try to visualize in the front, you can see a rectangle, a clean rectangle. So this entire flat surface together with this curve is seen as a continuous rectangle. The height of this plate is given as 15. So I hope it is visible, 15. So this thickness, this height is 15. So let us draw a rectangle, okay, resembling this part. So I will draw a dark line first, but remember its length. Its length is not till the center. You have to add 6 more. So the length of this edge, you need to add 6 millimeter more. So from this center of the circle, we need to add 6 more. So that is how the base plate is drawn dark over here. So say I have drawn the base plate dark, but remember it is 6 millimeter beyond the center of the circle. So this is the center of the circle. If you carefully observe, you need to move 6 millimeter further. So that is what I have done. From the center, I have moved 6 millimeter further. Now this height is 15, and you need to draw straight unless it is tangent to the semicircle. So what we'll do is, height is 15, so we'll mark 15 over here. Okay, then from here, let us draw a light horizontal line. And from here, we will extend, we'll make this darker because in the question this edge is seen. And even this edge is seen. So even this edge is seen. So we will draw those edges dark. So after both the edges are shown dark, so that is how the plate is being shown. The same plate you can see here also. Now the question is, how will this inclined surface look like? So if you look in the front view and if you extend this here, the inclined surface will be seen as an apparent rectangle. Apparent means reduced. So you can see that this inclined surface will be seen as a vertical rectangle. And see there is, if you look at this rib, you can see dark lines on both the sides. So there is a change of surface, isn't it? So this vertical surface of the base plate meets with the rib. So whenever two surfaces meet, an edge is formed. So this dark line has to be there. Even if you look here, this flat surface of the cylinder meets with the inclined surface of the rib. So that is why this edge is formed. So there is a plate of thickness 12 mm connecting the cylinder and the base plate. So we have the cylinder here and the base plate is here. So we need to connect them by a rib. So 6 millimeter on either side. So one side 6 is already marked. We need to mark 6 on one more side. And from here we will extend this beyond further, and even from this side. So you can see that I have marked 6 millimeter on either side. Okay, so that is how rib number 2 is ready. So in the front view, when you observe, you can only see this 12 mm thickness of the rib. You cannot see the surface trapezium from the front. Okay, now one new thing has come out. Look at rib number 1, and if you look at this line, you will find that after some time the line disappears. So what is happening is, this edge of the rib and the circular edge, they meet together at a point. So a new term has come out. So whenever you find a rib joining a circular surface, that point is called as a merge. Merge means you won't be able to make out the difference. So that point is called as a merge point. Even at the bottom you can see this straight edge of the rib joins with the circular edge of the cylinder and they form a merge point over here. So there are two merge points. So let us try to analyze rib number 1 from the front view. So this rib, if you observe, you can see this edge. You cannot see the behind edge. You can see the front edge. So whenever you see this kind of merge point, you have to understand that this rib is tangent with both the circles. Okay, so this rib has to be tangent with both the cylinders. So how to draw that? So very simple. This is your scale. You align tangent with the outer circle and with the outer semicircle. You align tangent to both and then draw a dark line like this. So that is how this rib number 1 is ready. Okay, so this is the front view what we've drawn till now. Now you can see that there are no hidden lines in the front view because from the front what is happening is all the rear edges. For example, look at this rear edge. So this rear edge cannot be seen from the front, but it overlaps with the front edge. It overlaps with some part of the circle, some part of this rib, and then this one. So there is no hidden line for this edge. So even if you look at these two edges, so the vertical edge will overlap with this inclined edge, isn't it? So the vertical edge will overlap with this inclined edge. So therefore, you should not draw hidden line for this edge even because they overlap. If you look at this edge, it overlaps with the front one. The behind circular edge overlaps with the front circular edge. So in other words, all the rear edge overlaps with the front one. So there are no hidden lines in the front view. The only thing what we need to do is we need to represent the circle by a center line. Okay, so for that I will erase a little. Okay, let me mark a small, how to start, you should mark a small medium dark plus sign on both the sides. And because it's a full circle over here, you need to draw big dash and small dash. It should slightly come out of the circle or cylinder from both the sides. Even here, after you mark the plus sign, you need to draw big dash and small dash. And here also. So it should slightly come out of the circle from all the sides. Now let us start with the top view. I need to make you understand one new important thing, that whenever you feel that the top is complex, how to start with the top view and draw step by step. So look in the top view and try to visualize the rear edge. See, look at this line what I'm marking. Look at this rear edge carefully. So when you look at the rear edge, all isko ek saath dekho. Try to visualize this edge together from here down till here. So you can see that if you look from behind, this behind edge lies on one single plane. It is one single plane. So in the top view, when you extend this line and the boundary of the circle, this is seen as one continuous line. So this kind of imagination all of you to develop. तो ऐसा सोचो कि पीछे दीवार है and against the wall this object is resting. तो ये एक wall है, wall के सामने ये object rest हो रहा है. So in the top view, because this rear edge rests on the wall, so the top view of the wall is a single line. Okay, so in other words, the rear edge of the object lies on one single plane or one single surface behind, and that's why this rear edge will be seen as one continuous line. और उसका लेंथ पूरा है, देखो ये कॉर्नर से लेकर till the boundary of the cylinder on the other side. So this is round, no? So here also this will be round going down, isn't it? Are you able to visualize? So you can see up to here. So this complete rear edge can be drawn as one single line, and that to see front view is here. तो आपको top view यहाँ से ऊपर देखना है, correct? So when you look from above, this is behind. Rear means behind. So in the top view, if you try to look here from the top, ऊपर से देखो. So this circular edge, this inclined edge, this small circular portion and this flat, सब मिलके यहाँ पे you can see a continuous edge, isn't it? So this type of imagination is required by all of us. It's very much essential. So ये पूरा एक continuous edge है. Okay, so this edge is ready. Now if you further move with this edge, see this edge is straight coming out and there is a radius 10 mm at the corner. To mark this radius 10, we know that यहाँ से 10 mm अंदर जाना है and you have to move 10 from inside. So the intersection will give you radius 10. Okay, so from the top view, try to observe thoroughly. So top view में, if you look here, yeah, so in the top view, let me adjust a little. Okay, so in the top view, this curve has to be somewhere here, isn't it? And that is radius 10. So it is seen that अगर आप compass से करोगे, if you do by compass, you have to from here you have to move in by 10, and from this you have to move out by 10. You will get a center. Then you need to draw a curve. So compass will take a lot of time. So to save our time in the examination, we can make use of pro circle. And now see radius is 10. So what is the diameter? 20. So in this pro circle, all these numbers are diameter. So you need to select diameter 20, that is radius 10. But that there are some pro circles where these numbers are radius. So to make out whether it is radius, what is or diameter, you just place the scale behind and check whether the diameter is equal to the number what is written. So here if I keep the scale at 20, it shows 20. It means this is diameter. So radius is 10 and that is what we need. So I'll align the 20 ka circle tangent to both the lines and I will draw a dark line like this. So I will draw quarter circle. See how quickly we can draw a circle. And then as per the question, this edge has to be darkened. So we'll darken this edge. Okay, so once this edge is darkened, now look in the top view again. See this straight edge, this circular edge and this straight up to here can be seen clearly as a continuous surface because ये जो पूरा surface है, this complete surface lies on one single plane, isn't it? So in the top view, this one single plane concept is seen as a line. तो ये जो पूरा surface है, this vertical surface in the top view, if you observe, it is seen. So let us project from here. तो यहाँ से लेके यहाँ तक it is seen as a continuous line because this is one single plane. But this continuous line is not till the end of the box. It is till this point. And see this point in the front view, if you try to recognize, it is over here. Okay, so I need to project this point down. And this straight edge after the curve, this straight edge, this and this one, it should be drawn till this point. So till the projected point, I need to draw a dark line. So these were the three important lines what I wanted you to make you understand. Okay, now very important part. Let us talk about this rib of 10 mm. So if you look at the rib of 10 mm, the rear edge you have already drawn as a continuous line. Now let us talk about the front edge. So this front edge in the top view, if you look here, it is seen as a line. So this edge will be seen as a continuous line. But the length of this edge is only between the merging points. And the width is 10, isn't it? So if you can project the merging points from the front view, so that will give you the length of the rib and the width is 10. So in the front view, what you should do is, wherever this line just intersects the circle, just intersects means somewhere here. Okay, so I'll mark a point. Similarly, wherever this rib just intersects the semicircle, that is here. So these two are our merging points. Okay, same way here, you can see that these two are the merging points. In the top view, the length of this line will be equal to the merging length. So when you look in the top view from here, so this merging point you need to project down. So I will extend this merging point down and even this one down. I'll take a longer scale, extend little bit further down. So you can project only where it till you need. It's not compulsory to project throughout the top view. So now these two light lines, what you can see, that is the length of the rib and width is 10 from behind. So we need to move 10 mm from behind. So here I'll mark 10 millimeter and I will darken that 10 mm width only between the merging lines. See here, only in between this, not beyond this. Now the question arises, should we darken this edge and should we darken this edge? So the answer is with the question itself. Is there any dark line here? Answer is no. Is there any dark line here? Answer is no. And dark line means what? Change of surface. But this is a continuous surface. Look at the rib and the cylinder. It's a continuous surface. You can't see any sudden change. So there should not be any dark line here and here. Okay, so I hope this part is clear. So the rib should only be between both the merging points. That's all. Okay, now moving further, once the rib is ready, let us try to draw the top view of the cylinder now. Okay, so we'll do that. Okay, now we need to visualize some important part. If I try to look at this object from this side, okay, so if I want to slightly turn and if I want to show it here, so this is the cylinder, this is the center of the cylinder, right? So here you can see that cylinder. So let us slightly turn the object. Okay, so now I have turned the object on the other side, and this is what you need to visualize. Okay, so from this side the object will look like this. Now let us draw the top view of the cylinder. So I will show you first the right half. So in the top view, this circular edge, when you project, it is seen as a straight line, isn't it? You can see this boundary, and the width of the boundary is 50. See, 50 is from here to here. So you can say that even this is 50. So this 50 can be seen completely. Then you can see the rear edge, which you already drawn. See, you already drawn this. You have drawn the rib which was merging. But if you look at the other side, look at the left side. So in the left side, when you look in the top view, from this point, you can see this boundary. Okay, that is quite obvious. But is this length 50 or is it less than that? Yes, the answer is less than 50. 50 minus 10, that is 40. So you have to assume that any given object in orthographic is made up of one single piece of block. It means if you look at this edge, it is only till here. You should not assume that this edge is penetrating inside. Neither this edge is penetrating inside, nor this edge is penetrating down. So the edge is present only till where you can see. So it is assumed that all objects in orthographic are made up of one single piece of block. So in the top view, I wanted to make you realize that, see, this boundary can be seen in the top view up to 50 mm, but the other side boundary will be seen only up to 40 mm. So this length is only up to 40, and the merging point will be slightly inside. So this will be 40 millimeter and this will be 50. So that is how the top view of the cylinder will look like. Three lines, one is of 40 mm length, other is of 50, and this line will be equal to diameter of the circle. So I hope this concept is clear. So in the top view, you need to visualize this circular surface as a flat surface. So when you compress it like a sponge, this will be seen like a rectangle of one boundary 40 and the opposite boundary is 50. Okay, so opposite boundary is throughout 50, but this is only 40. So now moving further, so in the top view when you observe, you can see this circular surface. So the right side point is 50 millimeter deep, whereas the left one is only 40 mm deep. How did I come to know? From the question that this is 40 millimeter deep and the opposite one is 50 millimeter deep. So let us project this to diameter of the circle. So the right side is already projected. Left side boundary need to project. So from here I will align the scale. So say I have projected this boundary down. So now you need to move from this point by 40. and from this point by 50. Okay, so it's very clear from the top view. You need to move by 40, leaving the rib 10 millimeter, and on the other side you need to move by 50. Okay, so proceeding with this part, from here I'll mark 40. Okay, so I'll repeat again. From here you need to move down by 40, and from this point you need to move down by 50. So they are unequal, as you discussed this part. So the left side is 40 mm deep, the right side is 50 mm deep. They are unequal. So in the top view, this rectangle will be seen as 50 and 40. Okay, so let me align with this part. So now this horizontal line, what I'm going to draw, see this line, what I just drawn, actually in the top view it's a circular edge. So you have to visualize this to be a circular edge, which is seen as a straight line. Now this boundary is the right side boundary of the cylinder, what you can see, and this is the left side boundary. Both are unequal by 10 millimeter. So if you look from far enough, don't visualize this as a flat surface. For some time assume that this is a curved part. So this is a curved part like this. It's a spherical surface which is seen as a flat surface. So that imagination is required. Well, now as we know that whenever you show a circular surface, it has to be supported by axis line. So the axis line is already ready in the front view. So in the front view you can see there is an axis line over here. I'll align the scale with that axis line. Okay, and let me draw big dash and small dash just in and around the cylinder. See, cylinder ends here, so the axis line should end somewhere beyond that. Okay, so this part of the cylinder is very clear. So similarly move on to the next part of the cylinder. So now all of you will focus on this cylinder now. So in the top view, this circular edge, if you project, will be seen as a straight line, isn't it? Then this boundary is seen fully till 70 millimeter. Okay, this one is 70. But if you look on from this boundary, from the other side boundary, this boundary, that is not till 70 because there is a plate 10 mm thick. So if this is 70, that will be 60. So you can see three lines of unequal length. So one will be 60. Then this is the circular edge seen as a straight line, and this edge will go up to 70 mm boundary. So that is how the top view of the semi-cylinder looks like. So for that, this is the semi-cylinder part, right? So at the top, from top view when you observe, and if you project parallel rays of light, you can see only this part of the cylinder which is illuminated. So both the boundaries needs to project down. Now carefully look here. The left side boundary, that is this one, will be seen up to 70 millimeter. This is 70, so this will also be 70. Whereas the right side boundary on the other side is not up to 70 because there is a rib in between. So you can see only up to 60. So let us project these 2 points. So I'll align the roller scale, move parallel, and see this is 60. So obviously you have to understand, out of 70 you utilize 10. So the balance part has to be dark. And here this is full 70. Okay, so let me align the scale. So you can see that this portion is the circular surface. This portion is the circular surface which is seen as a rectangle. So automatically you are going to get a side rectangle. So that is nothing but in a top view, it is this side rectangle with a radius of 10 mm. So that automatically comes out. Hope the view is clear till here. Now proceeding further, the question is, in the top view, will you be able to see this inclined surface coming out? Will this 12 mm plate be seen, yes or no? So in the top view, what you do is that if you extend this line and if you extend this line, so in the top view, because this is coming out, this straight line will be seen here. Then this inclined lines will be seen apparent. So this sort of rectangle will be seen, but that of reduced size. So in the top view, beyond the cylinder, you can see 3 such lines that belongs to the rib. And this rib in the front view is over here. This is the same rib, isn't it? So try to compare. So this inclined surface, that is the rib, is same as this rib. So I need to project this down and draw that portion dark which can be seen. So from here, if I align this part, so one edge is dark over here and the second one is on this side. So now carefully observe this rectangle what we just now drawn. Okay, so I need to project a little. Yeah, now once this is done, what is left now? Obviously our favorite hidden lines are left. So let us see some easiest hidden lines and then we'll see the difficult one. So the easiest hidden line what can be understood is, so at this point of time you should be able to understand that circular holes first and second are easy to understand because they cannot be seen from the top view. So this hole is of diameter 36 and it travels 50 millimeter inside. How much 50? Because the depth of the hole is not given. So if I put my pencil from here, it should come out from the other side. So the depth of the hole will be 50 itself, isn't it? Whereas if you look at this circular edge, the depth of the hole is again not specified. But again if I put my pencil from here, it should come out from the other side. So the width has to be 70. So this 1, 2, 3, 4 hidden lines can be drawn corresponding to the circle, and that can be easily made out from the question itself. So this is that circle which belongs to the semicircular portion. So if I can extend this and draw a hidden line, so let me first extend it light. Yeah, so that hidden line is throughout. So I will keep the scale over here and we will draw neat hidden lines, and you have to follow rule number 1 that the hidden line should intersect the dark lines at both the sides, and even on this side these are the hidden lines. See, the last hidden line can be longer a bit to make it to intersect. That doesn't matter. Now because this is a circular surface, it has to be supported by, yes, axis line. So let me align the axis line over here. Now because the circular surface, the inner circular surface is longer, I need to extend the axis line slightly beyond that. So over here, big dash and small dash. So that is how the axis line is ready. Now coming back to the next part, see there is a circular cavity here which will not be seen from the top view. So both these boundaries left and right I need to project down and show hidden line within this cylinder. So cylinder is only from year to year, remember that. It's from year to year, it is not 70. So the above cylinder is only 50 millimeter deep. The bottom one is full 70. So this circular hole will also be 50 mm deep. So from here if you align the scale and if you roll down, so light line over here, and from here one more light line down. So if you align the scale, you will get hidden line which is 50 mm deep. So we will double trace and draw neat hidden line. The last line can be longer a bit, no problem. Same way here also. So this two hidden lines represents that there is a circular edge which is going inside and the depth is throughout. Okay, now there are two edges more to be drawn hidden, but before that there is some new thing what you have to learn about this merging part from the top view. See, if you look at the diagram or any view, each and every dark line intersects some another dark line. See, it intersects some or the other dark line, isn't it? But these are the two dark lines which are left alone and they do not intersect any of the dark lines. So if you look at the object around and if you look at any view what you have drawn till today, each and every dark line will intersect some another dark line. But these are the only two points which doesn't intersect any of the dark line. It means there is some mistake you have to understand. So this dark edge is left alone at both the sides. So what we need to do is, so what is happening is, try to visualize a small surface of 10 mm is merging with a large surface of 50. So this point is called merging point. So small surface of 10 mm merges means it joins such that you won't be able to understand the difference. That is called merging. The small surface of 10 mm merges with a large surface of 50, and here a small surface of 10 mm merges with a large surface of 70. So I mean to say that if I enlarge a little, here what is happening, this is the small surface of 10, isn't it? And this is the large surface of 50. So a small surface of 10 mm is joining hands with a large surface of 50. So you need to show one freehand arc. Look at this arc, a freehand arc. This arc what I have shown just now is the symbol of merging. Let me show it on the other side. See how to show that arc. I will enlarge further. Yeah, now look at this. See, you're already drawn straight up to the merging point, right? So till merging point you should maintain straight. Now what is happening, see, look here again, a small surface of 10, so this thickness is 10, is merging with a large surface of 70. So merging arc should be pointed towards the larger surface. So larger surface is 70. So beyond this you need to draw freehand arc, beyond that straight line. So you're drawn straight line between the merging point, beyond that you should draw arc. Okay, so this arc should be drawn beyond the merging point. So it is just a curve. So again it is straight edge up to here, and beyond the straight edge you need to draw a freehand arc, a small arc on either sides. So this is the symbol of merging. So when you should draw this merging arc, you should draw the merging arc whenever you find that a rib is joined with a circular edge. Okay, this is called merging. So let me zoom in a little. Okay, so whenever you find in the question that this kind of rib is there is a rib which joins with a circular part, that is called merging. So for the merging in the top view you will get this kind of circular arc. Okay, now what is left in the top view, let us quickly wind up. So in the top view, see, there is a huge cylinder, and exactly below the cylinder there is an edge, what I am highlighting, which you cannot see from top view. So this edge you cannot see from the top view. Same way in the top view, this circular edge going inside, or if you extend this down, this edge you cannot see from the top view. So there is an L-shaped edge which is hidden exactly below the cylinder. Okay, suppose this cylinder was not there, and if only rib, if you observe, so the rib would have been seen like this here. Yeah, so that is how the rib looks like. So if the cylinder is removed, then the rib would have been seen like this, L shape. So this edge and this edge, both these edges you cannot make out from the top view because there is a cylinder which is overlapping. Okay, so for the last time, observe thoroughly from the top view. You can only see the circular surface, correct? But exactly below this there are two edges which is hidden below the cylinder. So you need to draw that as hidden line. So let us see where it is here. So if you look at the first part, look at this edge, what I am talking about. It is exactly in line with this rib, and that to the left side of the edge. So if you look at this edge, you need to extend hidden. That is what I want to say. You need to extend hidden. But till where? So this hidden line you need to extend leaving 10 from behind. So once you leave 10 from behind, you need to take an L-shaped turn. So see, 10 from behind means this rib is 10, isn't it? So if I extend this here, you need to draw hidden line till here and then take an L-shaped turn. So this hidden line represents this L-shaped part. Okay, so you are supposed to show by pencil. What I am doing is I am showing by separate pen so that you can understand it. But remember, all of you have to show by pencil itself. So let me extend this 10 millimeter first. I extended 10 mm. Now carefully look here. This object line, okay, this object line and the hidden line what I'm going to show, they are in continuation. So you need to leave space. So from here when you align the scale, so you can see that there is a small space what is left. Okay, if I enlarge a bit, so you need to leave such kind of space whenever object line and hidden line are in continuation. So this edge what has gone inside by red color, that is this one, that is this edge. Now you need to take an L-shaped turn. So from here if you align the scale and if you move up, so from the curved part leaving a gap of 2 mm, you need to take an L-shaped turn. Now see once again the dark line and the hidden line are in continuation, so here you need to leave space. And whenever two dark lines meet, rule number 3, sorry, dotted line, whenever two hidden lines meet, the corner should form L shape. So that is why this L shape has to be here. So you have to make a proper L shape here and you need to leave space on this side. Yeah, so this was the hidden surface what I was talking about. Now there is a last hidden line what we need to learn and understand. What is that? Let us see. The last hidden line. So zoom in a little. Okay. Now as I told you, you cannot see this edge because of the cylinder. Similarly, if you look from this side and look at this diagram, so in the top view you can see the circular surface, isn't it? But exactly below that this edge will not be seen. Or you can say wherever the cylinder and the rib intersects, there is an edge, isn't it? See, try to move your hand on this surface. So this part is circular. When you move your hand down, you suddenly change over to a flat surface. So that sudden change means there is an edge, and that edge in the top view is same as this one, both are overlapping. So in the top view, this circular edge, when you again move your hand, you're moving smooth on a curved surface. Suddenly at a point you move on a vertical surface. So the intersection of circular and vertical surface will form an edge, and that edge you cannot see from the top view because the cylinder is in between the observer and that edge. So this edge is by observation, that edge is 50 mm long. So see from this corner. Okay, so if you look from this corner, there is an edge going inside, isn't it? And that edge is how much? Till the end of the object, that is 50 mm long. So that edge in the front view, if you observe, it is this one. So in projection to that, see some portion you already drawn dark, and remaining you need to leave space and draw hidden. So I will show by different color. You have to show by pencil only. So from here, if you draw hidden line, so at the bottom you need to leave space. So again if I enlarge, yeah, this kind of space is required whenever object line and hidden line are in continuation. So this object line is in continuation with hidden line. So here you need to leave space. So remember the red line is only till here and it takes an L-shaped turn, whereas the green line is till the end. Okay, so that is how the top view is almost done. So we have completed the top view in all respect. All hidden lines are shown. So which are the hidden lines? Once again revision. One is this circular hole, second is this circular hole, third is this L shape, and fourth is the same edge but on the other side. So these are the 4 hidden lines what we need to show. Okay, now once the front view and top view is ready, let us start with the side view of the object. Its side view is comparatively simple. So the first flat surface is this rectangle of height 15 and width 70. So if you try to find out this height and width on the remaining 2 views, so this same surface, okay, yeah, so this surface which is 15 mm high is same as this height 15, and the width is 70, isn't it? So that width is same as this width. So we need to project 15 from here and 70 from the top view. So let us do that quickly. So this dimension is, this height is 15. So from here I'll extend this little above. and we will draw this dark double trace, left to right, right to left. Okay, so hope by this time it is clear that this is a flat surface, whereas this is a curved surface. So you can, at the max, you can see curved surface till here. So even this curved surface in the side view, when you project, it will be seen as a rectangle only, isn't it? So up till the curved surface, it will be seen as a pure rectangle. So straight plus curve is a total rectangle. That is what we have drawn here. So once this is ready, let us move up now and carefully observe. Look in the side. So this circular edge, inclined, again straight, all together if you look here, it lies on one single plane as you done in the top view. The rear edge of the object lies in one single plane behind. Okay, hope it's clear. This is that wall against which the object rests. So this total edge from top to bottom is seen as one single vertical line. So try to observe this entire edge from top to bottom in the side view will be seen as one single vertical line because it lies on one single plane. Okay, and that too on the side view. If you look here, it is on the left side. So in the left side, if you look at the diagram, look from the side, this straight edge, circular edge, inclined, again circle, together if you look, it is seen as one single vertical line. So that we need to draw here. Okay, so that edge is ready. So once that edge is ready, you can see rib. So the rear edge is ready. So the next edge, if you look in the side view, it is seen as a vertical line. But what about its height? How much it is? So the height of this edge must be equal to the gap between the merging points. And the width is 10. So width 10 millimeter is same as this width in the top view. But if you look at the height of this rib, you'll get from the front view. So where it is? In the front view, we have marked two merging points. So if I can project this here and width 10 mm from here, I will get the merging rib. So from here, if I start with, I will extend this down, project here. Then from here, we will roll and project the next merging point. So if you extend both the merging points a bit, so this is your height of the rib, that is the merging rib. So this merging edge of the rib is in between this, and the width is 10 millimeter. So that 10 millimeter I will extend from top view and I will transfer it to the side view. So you can very well see by doing this, I will get a dark line in between the merging lines. So that is how this rib is drawn. In between the merging lines, it is straight. So this, in the side view, we have drawn this surface. Okay. Now let us see in the side view. See, this portion is straight up to some extent, then it is curved, isn't it? So in the side view, this entire surface will be seen. It's like a mountain. So you can see this part. Up to where? But up to the boundary of the cylinder. So in the side view, if you compare, this boundary is nothing but the top part of the semicircle, that is this one. So in the side view, when you look here, this circular surface can be seen, but up to where? Up to the topmost boundary. So the topmost boundary, we need to extend from here and transfer it in the side view. Yeah, so see, I have projected this here till the end. Now what is the width of this? How much is the width of this? So it is 70 minus behind 10. So this is 60 mm width, and that 60 in the top view is from here to here. Okay, this is 60. So that is already projected if you look here. So in the side view, what you should do is, in the side view, the topmost boundary what is being projected, that needs to be darkened till here. So this horizontal line is the boundary, and the see rib is interfering, the rib straight edge is interfering beyond the boundary. Okay, so in the side view, this merging point is beyond the boundary. So boundary is still here and merging point is little down. Now apart from that, it is very clear that this circular edge and straight edge in the side view. So when you look in the side view, this circular edge and the straight edge together is seen as a continuous line. So here we need to close this. See, you're drawn vertical, no doubt, but actually it is partially curve and partially straight, partially curve, partially straight. So now, is the surface circular or flat? The answer is it's circular, and circular surface should be supported by what? Axis line. So if you stand in the side from here, this axis is moving vertically inside. Sorry, horizontally inside. Horizontally it is moving inside. So that axis has to be somewhere here horizontally. Or even if you look here, look at this plus sign what you marked. So in connection to that, we need to show axis line over here, a combination of big dash and small dash. So it's a curved surface. So we need to show medium dark axis line. Okay. So once this curved surface is ready, you can see one more curved surface on the top. The cylinder will also be seen, right? So you can see at the max up to the boundary, and boundary is nothing but if you look here, if you look at this is the boundary. So side view se dekho, look in this from the side view. At the max you can see up to the boundary, and boundary is nothing but the box. But what is the width of this boundary? It is not 70, it is 50. And width you'll always get from top view. So top view, see this is 50, this cylinder is 50. So I need to extend this in the side. Okay, so we will extend this cylinder in the side. So in the side view, when you observe, apart from this boundary, so you can see this boundary, no doubt, but apart from the boundary, this circular edge will be seen as a vertical line, and that circular edge in our front view is here. So in the side view, when you observe, this circular edge will be seen as a vertical line, but from here till here. So if you try to recognize the cylinder in the side view, it starts from here, then you need to come down till where, but so in the side view, this circular edge is seen as a straight line. So you can see that edge up to this intersection of rib and cylinder. So in the side view, we need to align and project this here. So I need to darken these three lines, first, second and third, to get the cylinder. Yeah, so to begin with, I will darken this edge first. So this is 50 millimeter. This is 50 millimeter long. Then we need to come down equal to diameter and then up till the rib. So in the side view, if you carefully observe, first line boundary, second circular edge, and third the intersection of this rib and circle. So it's a straight line going inside. So that is what is being drawn. Now as you're drawn merging point, merging arc in the top view, similarly in the side view, if you look here, this dark line is not intersecting any of the dark lines, whereas other dark lines are intersecting some or the other. It means here something is missing you to understand. So a small surface of 10 mm is merging with a large surface of 50. So a freehand arc beyond the straight line, this projected line, beyond this line you need to show an arc. Same way here, let me enlarge. So you can see that the merging point is slightly below this horizontal line. So a small surface of 10 mm merges with a large surface of 70, isn't it? So this surface is 70 mm, this is only 10. So the arc should be towards 70. So beyond this you should draw a freehand arc. Okay. It should be continuous and smooth arc. There should not be any sudden jerks. So this is the symbol of merging, what you do compulsory show in both the views. Okay, so hope this is clear. Now some very important lines what I am going to discuss is, what about this rib number 1 in the side view? So the answer is, when you look in the side, see, and if you project something here, try to visualize, you can see everything what is above this plane, correct? You cannot see what is below this plane. So if you look at the edge of this rib, you can see some portion of the inclined and remaining cannot be seen. So you can see some inclined edge, remaining cannot be seen because some portion of the edge is above this plane and remaining is below. So if you try to connect the top cylinder with the base, that is that inclined edge, what do you think about? So this the rib will start from here, one number rib will start from here and it will go down till here, but some portion you can see and remaining is inclined. So how will you achieve that? So align your scale and see, some portion you have to draw it dark as I have done, and remaining you need to leave a small space and draw a hidden line like this. So see, let us zoom a little. So this rib is seen dark up to some extent. So you can see dark up to here and the remaining edge is hidden. Now what else is left in the side view? Let us understand that. So obviously in the side view you cannot see these two circular cavities which is moving horizontally inside. One is 50 millimeter deep, another is 70 millimeter deep. Apart from that, one very important and the last part what you cannot see in the side view is, so all of you try to visualize from the side. As I told you that you can see everything above this plane. So this plane corresponds to the boundary of this semi-cylinder. So you can see everything what is above, you cannot see what is below. So if you try to visualize from the side, you cannot see this vertical edge going down, isn't it? So this edge will not be seen, as you cannot see this edge and you have drawn already the hidden lines for this. Similarly, even this edge you cannot see going down, and that moves down to meet the base plate. So in this diagram, this edge has to be shown hidden. This portion should be shown hidden to meet the base plate. So this part is hidden from here to here. And if you try to visualize in this diagram and try to find out where is this edge, you will come to know that in the side view, when you look from side, you can see everything above this line. So this much edge will be seen, you cannot see what is below. So this portion of the edge will not be seen. You can see the above part, but the bottom half will not be seen. So if you try to project this, you come to know that edge is from here to here. So let us align a scale and draw hidden line. So now see, the dark line and the hidden line what I am going to draw, they are in continuation. So you need to leave some space and then you have to show hidden line. That hidden line should touch the dark line at the bottom. So it should touch the dark line over here. Now the last two hidden lines, what is left is, in the side view, this circular cavity you cannot see of diameter 36 and the depth is 50 mm. So we need to draw two hidden lines corresponding to the top boundary and the bottom boundary. So this circular edge you cannot, this circular hole or the cavity you cannot see from the side. So you need to project the top and the bottom boundary and draw hidden lines accordingly. So let us do that. Okay, so I will project this here. So it is from left side to right side, double trace. So this is the top boundary of the circular surface. Similarly, the bottom boundary, we need to complete that here. So hidden line should be double trace, neatly drawn, less gap and more length. And it should be perpendicular, all four sides should intersect. Also the surface is circular, so we need to draw the axis line, horizontal axis line, which is a combination of big dash and small dash, medium dark line. So that is how this axis line represents that the surface is circular, and the hidden line represents that there is a circular cavity which is going inside. So the doubt is that how can you say this is a circular cavity? It can be a square cavity also. So to clear that doubt, in engineering graphics, minimum 2 views are drawn. So if you compare both the views and if you extend the hidden lines, you'll come to know that the cavity is circular and not square. Similarly, at the end, you cannot see one more circular cavity of diameter 24 and depth is throughout 70, and that is this circle. So we can align this one and we can extend this here. And we can draw neat hidden line. So I have drawn that partial. I will complete that. So further I will align this. So let it cut this hidden line, but it should be perpendicular with the object line at the end. So that is how the complete side view is done. So I hope it is very clear that this edge is the rib, what you can see partially, and remaining is hidden. So that we have already cleared that in the side view. This edge is the rib, what you can see up to some extent, and remaining is hidden. So that is this part. And this vertical edge belongs to this edge, what you cannot see from side. In other words, the edges of number 1 will not be seen. Achha, one more thing, you cannot see this edge also. Then why we have not drawn hidden line for this? Yes, so the answer is this hidden line in the side view, it overlaps with the front edge. So we cannot draw hidden line for the one which overlaps. Okay, so that is how we have drawn all the 3 views. Now as we know that without dimensions, drawing has no meaning. So let us quickly show the dimensions. So for length, first of all, we need to show, we cannot add and show 134. We need to split 40, 75. So let us show first 40 and 75 and then we'll see the remaining part. So here 40 is from this point or this boundary till the center of the smaller circle, that is 40. So here we can draw medium dark extension line. This is 40, so we can extend that line, and 75 is still here. So here we can show, leave a gap of 8. So this gap is around 8 to 10 mm. We can draw one medium dark extension line. Okay, we can show arrowhead over here. And we can write this as 40. And this is 75. But that will not give us the total length. What we had done was, after adding 40 and 75, we have subtracted 6 mm. But in the question 6 is not given, 12 is given. So we need to show this 12. So this dimension is 12. But as we know that we need to show smaller dimension first, followed by larger one. So here there is no space to give 12. So one can show 12 in the top view also. See even this is the same 12. This rectangle what is drawn from the top view, if you observe, it is this rectangle itself. And that is 12. So we can show 12 here also. So from here we need to draw extension line. And we can show 12 pointing with the arrow mark pointing inside. And we can write 12 in over here. Okay. Now coming back, after we have subtracted 6, we have added radius 25. So we have learned that whenever you want to show circular dimension, show in that view where you drawn circle. So radius 25 we need to show here. So I will just pinpoint this. It is advisable to immediately show the another circle also, that will add up to your 10 dimensions. So the smaller dimension, the smaller circle, I need to show arrow mark like this. So remember, these 2 arrow marks is for the inner circle and this arrow mark is for the outer circle. Now with your scale, what you do is that you don't forget to draw horizontal line. So you need to draw horizontal line on both the sides, and we should always write dimension above the line. So as specified in the question, they are given R25 and 536. So you should write R25 over here, and on the other side you can write 536 neatly. So you should have control over the text height and the arrowheads. So now if the reader wants to find the length of the object, what he or she can do is 40 millimeter plus 75. Then you can come down and subtract 6. Now this 6 you need to move up, and from here you need to add 25. So it's a long way through. That is how the reader can find the length of the object. So once length is over, now we need to give height. So height is, we need to add this 15. 15 needs to be shown, 65, and radius 25. Out of this, radius 25 is already shown. We only need to show 65 till the rib and 15 mm the base plate. So there are two options. We can spread dimension in side view. So in side view, this dimension is 15 and till center it is 65. So what we can do is, from here we can draw medium dark extension line till this base plate 15 mm, and then till the center of the above circle you can draw one more extension line. From here leave 8 to 10 mm gap, and here you show dimension 15 and 65. So this is 15 and here it is 65. So when you write this 65 and 15, try to write in the center of this line, approximately in the center, not right or left. Try to write in the center. So now when the reader wants to find the height, what it can be done is 15 plus 65, then project here and add radius 25. So that is how you get the total height. Now comes the width of the object. So width of the object is given as 70. Okay, and we can show that 70 in the top view. So this dimension is 70. So top view is only one dimension. So we can show 70 over here. So we can extend this here and here, and we can show 70 like this. So always write above the line. So when you just turn over, 70 is written above like this. So this is called as writing above the line. So look at 70, 65, 15. They are written above as a standard format. Now length, width and height is done. Let us count the dimensions. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have shown 8. We have to show 2 more. Okay. So this 50 mm can be shown in the top view. So let us show 50 here. So we can draw medium dark extension line, and we can show 50 here. Instead of 50, if someone else wants to show any other dimension, it can be shown. I think linear dimension is easy to show. Now see, there is no point in showing circular dimension because the examiner just wanted to know, are you aware of circular dimension, and you already shown here R25 and dia 36. So the examiner has understood that you know how to show circular dimension. So there is no need to show again here. Instead, if you show linear, you can complete your task quickly. So we have shown 9 dimensions. What else can be shown over here is, one can show this height 30. Okay. Or you can show this thickness 10. So let us see how to show this 10. So in the side view, this thickness is 10, isn't it? So from here we can draw medium dark extension line. And now when you draw extension line from here, you need to leave 2 mm gap from inside. So from inside you need to leave 2 mm gap, see, like this. The extension line should pass from inside the object. And then you can show a common line and write 10 over here. So this dimension is 10. So by this we complete all the 3 views of the object. So you can see all the 3 views.